Hello everyone, Devashish again from Dev's Learning Hub. So today we are going to discuss a very interesting topic, which is instantaneous velocity, difference between average and instantaneous velocity, and what is the role of calculus in calculating instantaneous velocity. So by this time already I have explained the high level concept of limit, for what the link is given in the description section below for this particular video. So if you want to have that video to understand the concept of limit, high level concept, please go through that. Here, by the way, the concept what I will utilize here, instantaneous speed, and how derivative actually helps to determine the instantaneous speed, and concept is same for the instantaneous velocity also. The speed is just a scalar one, and vector velocity we are considering the direction also along with the scalar part. So it's a vector one. So here I will explain speed actually. The concept is same. So now considering this particular picture, what is the average speed between A and B, point A and B? 80 kilometers in 4 hours the car has traveled. So 20 kilometers per hour, that is the average speed. But if I want to know the instantaneous speed, what is the instantaneous speed? Means at any given point in time, what is the speed of my car? So for that you have speedometer in the car, where you get the actual speed at any given point in time. The concept of speedometer is also this concept what I am going to explain now. So first I will represent the average speed graphically, how does it look like, and then I will transform this average velocity towards instantaneous velocity, and how calculus is coming into picture, how derivative is coming into picture, and limit is the motherhood of the entire calculus. It is the foundation of calculus, and how this limit is also useful in derivative, that you will understand here. If this is the graphical representation, towards x-axis it is time and towards y-axis it is distance. Right. So now if we see that the car is moving at a uniform speed, what does it mean? That means for every specific equal time interval, the car is moving the same distance. That means the distance by time ratio, that is equal. Okay. Now let's first assume if the car is moving in a uniform speed, how does it look like? How does it look like graphically? Right. So uniform speed means the ratio of distance by time, that is always equal. Now let's say how the graph looks like if the car runs in uniform speed, which is realistically very rare. So let's say at any given point in time, at 2 minutes, the distance of the car, that is 10 meter. 2 minutes. Then next in the 4 minutes it is 20 meter. Then in the next 6 minutes the distance it is 30. Next in 8 minutes it is 40. What does it mean actually? The distance versus time ratio, that is 10 by 2, 5 meter. Then next it is 20 by 4, 5, 30 by 6, 5, 40 by 8, 5. So that means the car is moving at a uniform speed where the distance versus time ratio is always equal. But realistically it is possible? It is very unlikely, because you know very well there will be traffic congestion, there will be traffic signal, there will be road condition, weather condition. Because of that you need to increase or decrease the speed of your car. That is how it happens. So therefore, if you see at any point, let's say it is 30 km per hour. Sometimes it's increasing the speed 60 km per hour. Then again it is decreasing at 20 km per hour. So the speed varies at any given point in time based on different conditions. Now let's say in case of uniform speed, the graph is a straight line where I am considering these 2 points, point A and point B. Now let's say, so this is point A and point B. Let's say the time, the initial time, that is Ti, and the final time where I'm in between this point A and B, I'm considering the average speed. Okay, and the final time, that is Tf, T suffix F, right? At point Ti, the distance, initial distance, that is, let's say it is di. d initial, d suffix I. Then it is the final distance, it is d suffix f. So what is this distance covered by this time? That means this is the distance covered, this is the time consumed to cover this distance. So what is this? This is actually TF minus TI. What is this? This is actually DF minus DI. So this is total DF. This is, so at time TI the distance is DI, at time TF the distance is DF. So what is the distance covered during this interval TF minus TI? That is DF minus DI. So what is the average speed? The average speed is S equals to DF minus DI by TF minus TI. So what is this actually? If you consider this particular triangle, that means this DF minus DI, that is actually the rise, and this TF minus TI, that is actually the run. So basically the speed is nothing but the rise by run. This is the ratio of rise by run. So rise by run means it is actually this slope. So actually you are considering the slope between 2 points. That is how actually it looks like for uniform speed. So whether you go for uniform speed or non-uniform speed, always you are taking the slope between 2 points. So for uniform speed, if you consider here, if you consider here, if you consider here, wherever you are considering at any given point in time, actually the slope is equal. That means that is how it is called average velocity or average speed. But for non-uniform speed, the graph will not be straight line. So now that I will show you, but you need to remember, when you are considering the speed, speed is nothing but rise by run, the ratio of rise by run, which is actually the slope between of the slope of the points between which points you are considering the average velocity or average speed. So this is the punchline. Speed equals to rise by run, or the ratio of distance traveled, total distance traveled by total consumed time. Now let's say the car is not moving in uniform speed. So definitely the position time or distance time graph, that will not be a straight line anymore. So let's say this is not a straight line. This looks like this. Okay. So now if there is a point A, I am considering another point here, it is B. So at point A and point B, let's say it is the time T1 and this is time T2, and at point A, right, that T1 versus what is the distance, that is D1, and for T2 the distance, it is D2. So if I draw a, because already I have explained what is the definition of speed, it is rise by run with respect to coordinate geometry, or it is distance by time ratio, right? So if we are considering the rise by run, that means you are actually considering the slope between 2 points. So it is the slope, right? So if this is the slope, actually if a straight line, it's actually a straight line, and my drawing is not so good. So if this is if a straight line intersect a curve at 2 points, that is called secant line, right? So this secant line, if I consider the rise versus run, that means what is the speed actually? Speed is d2 minus d1 by t2 minus t1, right? So if d2 minus, because that is how I already have explained, this is the rise versus run. So this point, this is actually d2 minus d1. And this area, this is actually this particular point. From this point between A and B, that is time consumed, this is T2 minus T1. So what is this? The D2 minus D1 by T2 minus T1, that is the speed. Now, if I reduce this time span, what I can say, the change in distance, that is delta D, and the change, the time elapsed for that is delta T. So speed is, that is delta D by delta T, the distance covered by total time, right? Delta D by delta T, that is the average speed. So what is the concept of limit? I already have explained. I explained that the value of a function at a given point, that is not limit. But what is limit? Limit is the value of a function at neighborhood of a given point. So when the point is, the value is approaching towards that point but not exactly at that point, that is the concept of limit. Now when you will reduce this point, let's say you are taking this point here, or you are taking this point here. So gradually what is happening, what is the slope is here, this. Now you will consider this one. Now you will consider this one. So gradually we can see the slope is actually decreasing. So when you are reducing this distance, when in between time, you are reducing the time, not distance, you are reducing the time T2 minus T1, that is a delta T, that is approaching towards 0. That means the secant line, that will be not intersecting the point curve anymore in 2 points. Secant line will be converted to a tangent. When this distance it is approaching, this time is approaching towards 0. It's not exactly 0 but towards 0. Towards 0 means it is infinitesimal small. So let's say it is 0.00000000111. So that is infinitesimal small, it is not 0 but tending towards 0. Then it is actually, the secant line is converted to a transform towards a tangent, and at that point whatever is the distance, that time ratio, that is called the instantaneous speed. So when S equals to delta D by delta T, the speed, that is the concept of speed. But where you have the secant line, but when this delta T, S equals to delta D by delta T, but this delta T tending towards 0, that is what the concept of instantaneous speed. That means at any given point in time, now I will show you with respect to the function how does it look like. That means the distance covered by time, but the interval I am taking is trending towards 0. This is where the concept of limit is coming into picture, and this is what it is called derivative, right? Then I will explain you with respect to function. Let's do that. Now assume distance, the relationship between distance is a function of time. Let's say distance D equals to function of time t. If distance D is a function of time t, then at a point, let's say it is, these 2 points are here, then at this point this is t equals to a, and this distance, the distance between these 2 points, where I am considering the average velocity between these 2 points, let's say this distance is h, this distance is h. That means this point is t equals to a plus h. So this is t equals to a, this is t equals to a plus h. Now if I consider at point t equals to a, what is d? D equals to here at d at t equals to a is function of a. So if distance d is a function of t, so at t equals to a, what is the distance, value of distance? Because I am not considering limit here, it is just the value of the function at a given point. So d equals to fa. Now at d at t equals to a plus h, it will be function of t plus h, right? So how does it look like? The speed looks algebraically, how does it look like? S equals to function of final position, final distance, it is function of t plus function of a plus h. So at t equals to a plus h, it is function of a plus h. So function of a plus h, final distance, and the initial distance, it is with respect to the function of a, and what is the time consumed? It is h. Now if this, for instantaneous speed, what did I say? This time is trending towards 0 but not equals to 0. That means h is trending towards 0. So what it will be? If it is, I am considering about the instant, this is average, this is the average speed avg. Now I am considering about the instantaneous speed. Then how does it look like? S, let's say SINT, S instantaneous, that means S, h is trending towards 0, the time consuming is trending towards 0. So that means actually I am taking the slope at that point, instantaneous speed. The concept, you understand the concept first, what is instantaneous speed. For average velocity, I am considering the slope of those 2 points. Between the points you are considering taking the average velocity, but instantaneous speed is at any given point in time you are considering the speed the way it is there in the in your speedometer. The same concept it is there, but there actually what is happening, I am considering at any given point in time means t is approaching towards 0. That time interval h is approaching towards 0 but not equals to 0. Therefore this second line is actually converting from second line to tangent. So at that point in time I am considering, therefore I am saying for instantaneous speed this time interval is approaching towards 0 and then remaining portion it remains same. So for average speed, function of a plus h minus function of a by h, where h is the consumed time, a is the initial time, a plus h is the final time, if a is the initial distance and f of a plus h is the final distance and h is the consumed time. So therefore it will be function of a plus h minus function of a by h. So that is how the instantaneous speed it looks like. As h tends to 0, that is function of a plus h minus function of a by h. That is the definition of instantaneous speed, and this is the concept of limit. This is the concept of derivative. So limit is the motherhood of derivative. Limit is the foundation of derivative. We are utilizing derivative or differential calculus to find out the instantaneous speed, but what we are using to find out the derivative, that is finally we are utilizing the limit. So I hope you understood the concept of the derivative here, right? So if you would like to understand the concept of limit also, please go through my earlier video for what the link is given in the description section below. तो क्या समझ में आता है हम लोग आप लोगों को? ठीक है, तो पंच लाइन यहाँ पे क्या है? average velocity total is equal to total distance covered by total time. But ये instantaneous speed क्या होता है? At any given point in time, what is the speed? तो एवरेज वेलोसिटी के लिए सेकेंड लाइन हम लोग कंसिडर करते हैं, लेकिन इंस्टैंटेनियस स्पीड के लिए हम लोग टेंजेंट को कंसिडर करते हैं. तो अगर आपको अच्छा लगा है, इफ यू लाइक ऑल ऑफ यू लाइक दिस वीडियो to understand the concept of average and instantaneous speed और limit and derivative कैसे यूज होता है यहाँ पे. So if you like this video, please click on the like button. अगर आपको अच्छा लगता है और this kind of video you want to get again and again, please subscribe my YouTube channel Dev's Learning App and also follow my Facebook page Dev's Learning App. Thank you very much.